this information, so you'd better stay here. Duncan will start with presenting the ICFP programming contest.
Thank you. Is this mic working okay? Good. Right, yes, welcome to the most fun part of the afternoon. We'll get to talk about the contest. So this year it was co-organised by volunteers from the University of Oxford Computer Science Department and from Welltype. And Nick and I were the co-chairs. Unfortunately, Nick can't be here, so I get to do the presentation all by myself. Very brief history of the contest, for those of you who don't know so much about it. It was started, this is the 17th year it's been running. It started in 1998, partly in response to the fact that the ACM's programming contest was, and still does, I believe, only allow imperative languages, only C, C++, and Java, I believe. It's still a disgrace. So in contrast, the ICFP programming contest is very, very open. It takes place on the internet, it's open to anybody, any size team, and in particular any programming language. And of course the hope when it was started, right, was that we'd be able to, at a level playing field, we would show that functional languages could hold their own. And so it takes place over a weekend, over 3 days, Friday midday to Monday midday, and there's also a 24-hour lightning round for people who can't do the full 3 days. The main thing that people win is bragging rights. There's a small cash prize, but mainly it's the bragging rights. So I will later on be declaring that something is the programming language of choice for discriminating hackers. A little brief aside on history. Some people who looked at the problem carefully might have noticed that there's certain similarities between this problem and one 10 years ago, which is the anthill one. And that's no coincidence. That year's problem has a special place in my heart because I was here 10 years ago receiving the prize as part of the programming team. So that problem is stuck in my memory. So, but I think we've done one better because we forced everybody to write 2 compilers rather than 1. I'll see more about that in a second. So this year's organisers, as I say, a team mainly from Oxford, Nick, myself, Pedro, Richard, Martin, and Marcelo. Okay, to set the scene, I'll just have to describe the problem, but you've got to think 80s. 80s pop culture, 80s computer games, 80s programming technology, and some 70s programming research. So there was this company in the 80s, it's now bankrupt, called Lamco. And they had this arcade game project called Lambda, or at least that was the internal name. I don't suppose they would have stuck with it. It never actually came to fruition, but we acquired a whole cache of documents about this project. Now, Lambda is a game where Lambda runs around in a maze, chomping pills, and trying to evade ghosts. And it bears a striking resemblance to a game that you're probably all familiar with. And in fact, we rather suspect Lamco of a bit of light industrial espionage. So the cache of documents that we obtained, it revealed that Lamco had built some rather interesting technology before they went bankrupt and failed totally. And so we thought it'd be fun this year to get the contestants in the contest to help us recreate some of this technology. Because in particular, although we had a lot of details about the hardware, we didn't have any of the software. So the documents also revealed that Lamco had a spectacularly dysfunctional development process. They had engineering rivalries, really serious, bad engineering rivalries. They had teams that were absolute fanatics about 8-bit microcontrollers and thought that was the be-all and end-all. And they had other teams which were absolute fanatics about Lisp and all things Lispy. And for this particular project, 2 of these teams were forced to work together with inevitable consequences. The solution that they built for this arcade game reflected, of course, as it always does, the teams that built the project, that built the solution. And so on the same motherboard, you had a whole bunch of 8-bit microcontrollers for running the Ghost AIs, and this great big custom Lisp CPU for running the Lambda AI. The reason they needed an AI for both was because they were trying to make a 2-player version, and we don't really understand why. So, the task we set everybody was basically to recreate the software that ran on this arcade hardware. And so for the lightning round, we asked everybody to build an AI for the Lambda programming for this Lisp CPU. And then for the full round, with the full 3-day version, they in addition had to write AIs for the ghosts, running on these little 8-bit microcontrollers. And these two things are totally different. One has a very, very imperative and low-level flavor to it, and the other is this weird, exotic CPU, very powerful, that's designed to be a target of a Lisp compiler. Totally opposite, and they had to write both. So here's Pavel from the StanFi team, sitting down, getting ready to read through our spec. So the spec included the game mechanics, the way that Lambda Man runs around the maze and all the ghosts and all the rules about how everything works. Has a complete specification of the ghost CPUs, and has a complete specification of the Lambda Man CPU. So there's quite a lot there. So here's Pavel, several cups of coffee later, struggling through 26 pages, or maybe he's up to page, I don't know if it's in total or he's only up to page 26. Anyway, so you have the Ghost CPU. The Ghost CPU is 8-bit everything. 8-bit registers, 8-bit address space, all those separate code and data address spaces. It uses interrupts for I/O, although not everything is 8-bit. There's actually a 10-bit maximum count for the number of instructions you're allowed to execute, which we thought was pretty generous. On the other hand, you have and this thing, by the way, was called the GHC, the Ghost CPU. That was what Lamco called it. Nothing to do with us. On the other hand, they called their Lisp CPU, they called it their General Compute Coprocessor, the GCC. And it's, as I said, totally different. It's got all of its registers are special purpose. It's got a hardware managed stack, and indeed a garbage collection in hardware heap. It's got enormous memory, at least for the time, for the early 80s. Lots of its instructions are special purpose, in particular lots of control flow for manipulating some of these stacks are very, very special. There's no general memory load store, nothing like that. And there's no I/O at all. It's a coprocessor. It just returns a result, and that's all it does. There's no interrupts, no modification. Oh, but there was some little sop to the imperative programmers in there. The engineers at some point had added a Pascal extension, which allowed a limited amount of mutation. But only limited. It wasn't not full mutation. And so we were wondering about these register names. In the Lamco spec, they were described as %E, %S, %D, and %E for the program counter, the data stack register, the control set register, and the environment. And we were, why? And then after the contest finished, we found in one of the boxes that we hadn't opened, there was another tech document we hadn't read, and that turned out to explain it all. It was a paper from 1978 by Peter Henderson called the Lisp Kit System, a software kit. And it explains that it's really SECD for the stack, environment, control, and dump. Well, it would have been much better if we'd known that before. Some participants noticed this, and I think I don't know, some did and some didn't. So this is what the normal SECD spec looks like. This is from Peter Henderson's paper, typeset pre-LaTeX with typewriter and pen for the tricky bits. And it fits on one slide, just. Whereas the documents that we got in in our dusty boxes, this is just the documentation for one instruction. So we have an English language explanation, assembler syntax, and then pseudocode for the effect on the machine in terms of manipulating the various registers. So, and then some of them are really quite large. This is not a RISC machine. And so here's Team StanFi again, trying to digest this specification. Right, so as you can see, the judges are cruel, but we're not that cruel. We decided to take a little bit of the donkey work out of the problem by giving people a reference implementation. And the goal of that was to make it a bit easier for the weaker teams, make it a bit more accessible, but we fully expected that the strong teams would have to re-implement their own anyway. So it gave a little bit of advantage to the weaker teams. And so what we included was basically a full simulator for everything. Simulator for the Lisp CPU, the Ghost CPU, the game mechanics, And it also included a debugger for the Lisp CPU. And it included some example programs for the Ghost AI and the LambdaMan AI. And it had animations and graphics, and you could really run it. I will show it to you in just a second. Before I do, I'm going to explain the problem of how do you, in a contest like this, how do you give people a reference implementation? Because we can't give them Haskell code because that would grossly advantage the teams that were using Haskell. But it has to run on any platform, right? I mean, you can't give them a binary. Well, you could, but then you have to do a virtual machine, and it gets very complicated. So the judges accept that JavaScript is the lingua franca of the internet, but the judges are also language snobs. So the solution was GHC.js, to take our reference implementation that we'd written in Haskell and to compile it to JavaScript. And this worked really well. So we used this compiler called GHC.js, which is a full-fat Haskell to JavaScript compiler. It's implemented in terms of GHC, so it has all the language extensions, all the front end, because it uses the GHC front end. And it works pretty well. It's a little bit tricky to set up at the moment, but it's rapidly maturing, and it works really well. It worked very well for us for this contest. We were able to take the big blob of JavaScript code that it generated and integrate it with a little bit of handwritten front-end code, which one of our student helpers wrote so that we didn't have to get our hands dirty. I can't emphasize this enough. We did not have any browser compatibility bugs. It just worked. We had bugs in the Haskell code, but we had no bugs arising from the use of GHC.js. It worked really nicely. So yes, a huge thank to Lloyd Stegman for his work on that, and also for helping us get things set up with it. And it was only 20 times slower than native code, which I thought was pretty good, actually. So we were achieving 0.2 million instructions per second in terms of SCCD instructions, at least on my browser, on my desktop, which is enough to run it. So let me give you a quick demo. So here we have you have to copy and paste your input. This is the LambdaMan AI, and then you've got the map that we're going to play on, and the code for the ghosts. So these are the trivial ones that we provided the contestants. So you load it up, and well, you can run. Now, because this is this LambdaMan is not very smart. What he does, he always goes right. I think load constant 1 return. Now, yeah, he goes right. But I think we specially constructed these ghosts so they don't eat him immediately. So it's not quite so boring. Anyway, so this is what the contestants had to play with. They could load up their code here and run it, and if they were writing their own simulator, they could compare. They're getting the same results, which is makes the spec a bit clearer. Yes, we also, let me stop that. Oh, it also has like a single step mode, so you can see what's really going on at tick 3043 when something weird happens. We also included a sort of lower level debugger for the LambdaMan CPU. So here's a trivial program that's going to add 21 to itself to return 42. So we can step through and you can see what goes on the various stacks. Here we apply, and it goes into the environment frames, and then we load, and so you can see what's going on. You've got the control. You've got all three. You've got the control stack, the environment stack, and the data stack. And finally, it returns and gives us 42. So again, this is useful for the contestants to be able to make sure they've implemented their simulator correctly, or they can just use the one as is, or it can help them debug their programs. It also includes one of the instructions is a breakpoint, so you can use it for debugging your program as well, not just your simulator. Okay, so I'll give you a little of what happened, at least from the judges' point of view, during the contest. I think this is I can't remember the name of this team, but they've mounted their projector vertically so that they can relax while they code. Well, I think one of them might be so relaxed maybe he's taking a nap. Well, it's a 3-day contest, so you have to sleep sometimes. So before the contest started, it's traditional to send out hints that don't reveal anything at all until afterwards when you go, oh, that's what it meant. So we tweeted LambdaMan, So thank you, Phil. Only makes sense afterwards, of course. We reminded participants to stock up on healthy fruit. For those of you who are not so familiar with Pac-Man, one of the bonuses you get is there's all these different kinds of fruit, like cherries and whatnot. And one of the teams did. They showed us. They stocked up on fruit, which is only to be commendable and very sensible over a long weekend, much better than pizza. Right, so beginning of the contest, major panic. Our deployment system broke down entirely, and we were the seconds were counting down, and we were on the telephone to each other, sort of trying not to sound too distressed. No point in shouting at each other. We eventually managed to push stuff out manually, and it came out a little bit late, but we got it out, and our blood pressure reduced slightly. For the first 5 hours, everybody, all the organisers were on hand to answer questions on IRC, because people, of course, are reading through the spec and finding all of the bugs in the spec, or just things that are unclear, or bugs in reference to implementation. And so we were scrambling the whole time to respond to people's questions and see if those are real problems or just people misunderstanding things. At one point, Nick and I had to very carefully reread one of the academic papers from the 80s to make sure that we really had done one of the really tricky instructions correctly. The recursive apply really is tricky. What worked very well actually was the fact that we were using our website was backed by Git, and people could go on GitHub and see what the differences were, so that when we said that we changed the spec, they could see did it affect them or not. They could just see the diff, and that actually worked out very nicely. We would recommend that to people, to organisers in the future. It also means you can do things much quicker. So after the initial rush subsided, we moved on to a shift system for the judges with 2 people on call at all times, and the rest of us went to sleep. End of the lightning round. It's quite fun to watch the submissions roll in. We were sitting there. We had a Google form, and so it was nice to see them all come in. Huge rush in the last few seconds, always, of course. And of course, at the end of the lightning round, we also released a spec update for the full round. Of course, most people actually guessed what the update was going to be. It was a little bit obvious. Well, it was either going to be a 2-player version, or it was going to be that now you had to program the ghost as well. And that's what it was. You had to program the ghost as well. We also revealed that Lambda Man actually had access to the ghost's programming code. Although it turned out that people didn't make much use of this fact. And I started hacking on a high score server, which of course I should have done beforehand. But there's so many things to do at the last minute. That was one of the things that didn't get through. End of day 2, things seemed to be going pretty well. People seemed to be happy. I was making good progress on my high score server. Yes, one of the really nice things, I mentioned lots of compilers got written that weekend. So yeah, one more compiler than one 10 years ago. Here's a team. I think their Lambda Man must have kept getting slimed by their ghosts. I liked that one. Right, and then after about a day and a half, I finished the high score server, and it went live. So people were able to submit their half-finished Lambda Man programs and run them against some house ghosts and see how they were doing. And that turned out really nicely. I was actually hosting it on my desktop at home, which ends up getting quite hot. It started beeping at one point. It was a very hot day. I had to take the side of the case off. Last sort of 12 hours or so, we added a couple more maps, and people were really making good use of the high score server. There was lots of competition going on there. People were getting towards the end of development of their AI programs and getting some increasingly good high scores on the high score server. And then at the end, again, we watched the high scores roll in, and were able to relax finally. 3 days intense. I don't know what it's like for the contestants anymore. I've not participated for several years, but I can assure you as the judges, it's really exhausting. Okay, just tell you a little bit about how we did the judging. So we decided to give people a little bit of leeway, allow them up to be up 3 minutes late. We found that we had enough resources to be able to run everyone against everyone. So that meant we didn't have to do a multi-stage, group stage kind of thing, knockout tournament. In the end, we got 94 teams submitting for the lightning round and 142 teams for the full round. For the lightning round, because in the lightning round, of course, it was just your ghosts versus the judges or the house ghosts. Sorry, the contestants Lambda Man versus the house ghosts. So there, it's really just based on the score that they get within each game. Whereas for the full round, it's we play them against each other, and so there it's based on how many wins and losses they get. And so we run each one on 10 maps for the lightning round, 10 maps for the full round. For the full round, as I say, we're running against each other, and then we give them 2 points for a win and 1 point for a draw. It turned out draws were quite common, which was a bit surprising. So what was going on there is that you run the Lambda Man of one team against the Ghost of the other, and then the other way around. And whichever Lambda Man gets a higher score is deemed to be the winner. But sometimes they ended up getting exactly the same score. And then for the judges' prize, it's totally at our discretion, but we decided that we would look at the performance of teams' ghosts, and also looking for teams that just had sort of cool and interesting stuff in their solution and described it nicely in their write-up. So the technology, we were able to, because we've been using this GAC.js stuff, we were able to use the exact same Haskell code for the judging as we've been giving to participants for their reference implementation. And we used the high score server as a basis for our judging server. And we ran this all on a cluster in the computer science department in Oxford. So we ended up running over 200,000 games on 75 machines. The final run, after we had to do a few trial runs, but the final run took about 8 hours. Most took just a minute or so to run, but some took about an hour to run. That's that wasn't the pie chart I was expecting. Here we are. Right. Everybody likes to know what the distribution of languages is. Maybe it's a slightly pointless graph or chart. Really, maybe you want to know. Keep an eye out later for the languages that come up in the top 15. But as you can see, there's Python, Haskell, C++, Lisp are all quite popular. This is in the full round. But this is across all teams, and if teams listed them multiple times, like use multiple languages, they get listed multiple times. Lightning round, pretty similar. Haskell and Python, again, very popular. C++, Ruby. A camel, a lot of camel as well. Less Java than expected. Oh, by the way, when it says GHC down there, that's assembly, right? Because that's the GHC was the ghost CPU. And in the next one, the GCC is the general compute coprocessor, so that's also assembly. That means that they were hand coding their Lambda Man AI in assembler. Right, what you've all been waiting for. Are you ready? Yeah. Come on, bit of enthusiasm. All right. These are not the real high scores. Come on. They don't all get 1,000. All right. So, first prize goes to Supermassive Black Concept, which is Pavel Lepin, who I hope is here. Is he here? Yes. Pavel is going to give a short. Do you have your laptop with you? Oh, yeah. He's going to give us a short presentation when I finish talking about his solution. So, it is my privilege to declare that Haskell is the programming language of choice. So, just come by here and get ready for when I finish. Oh, by the way, I'll come to that. Okay, are we ready? Second prize. Second prize goes to Team Unagi. Unfortunately, so Team Unagi are a very good team. They came first last year. Unfortunately, none of them can be here to receive it, unfortunately. so they just have to hear our praise. C++ is a fine programming language for many applications. And then third prize. Third prize goes to Team Diamond Princess. Pearl is also. Alright, and now we have, so the last two we have is the lightning round and the judges prize. The winner of the lightning round is Team Jabber.ru, which is Alexei. Unfortunately, Alexei also cannot be here. He's in Crimea, and the passport situation there is a little bit tricky at the moment. OCaml is very suitable for rapid prototyping. And finally, we have the judges' prize, which goes to Team Gaglium. I should say a little bit about what they did, why we chose them. So they used OCaml, and for starters, their Ghost was actually the best Ghost. It performed best against the house Lambda. But the thing that was really interesting about their solution was that they used OCaml as the source to write their Lambda, and they used the OCaml compiler, and they took the output from the compiler, or some stage through the compilation process, once it had been lowered down to Lambda terms or something, and they translated that into the SECD machine to run on the Lisp CPU, with a few limitations, of course. So it didn't include records or other certain things, but they were to take more or less full ML source, and so they're able to write the Lambda man in that. So we thought that was pretty cool. So I'm proud to declare that Team Gaglium are an extremely cool bunch of hackers. Okay, top scores for the full round. We've got Supermassive Black Hom set at the top here, Unagi, Diamond Princess, etc. So remember, the score here is the sum of the number of wins and losses. 2 for a win, 1 for a draw, 0 for a loss. One thing you notice is the distribution of languages is quite varied. We will publish the full list on the website for all teams. And for the lightning round, similarly, we've got Jabber.ru at the top there. This is actually very impressive. The maximum theoretical score here is 10,000. So I don't know if I sort of skipped over it earlier, but the scoring process there was that the top scoring team for any one map was given 1,000 points, and then all the other teams were given their proportion of that. So if you got half as many points as the team that did best on a particular map, then you would get 500. Right? So here, Jabber.ru is getting very close to sort of the maximum theoretical. It's very impressive.
Tell us about standard ML, yeah.
Standard ML, yeah.
Choice of language.
Oh, that's yeah. That's a good point. I haven't noticed that. I have to ask them. I don't know. That's self-reported. The choice of languages there. Okay. Right. Lots of thanks to various people before I hand over. Thanks particularly, of course, to the organising team. Who put an enormous amount of work in over the course of a year. Fortnightly meetings, and then the inevitable crunch at the end with hacking up the infrastructure. I want to give a big round of applause to the organising team. Pedro's here somewhere. Where are you? Oh, thank you. I also want to thank we had a number of student helpers, undergraduates at Oxford. In particular, Matthew wrote the JavaScript UI code for us. Also, special thanks to Loit Stigman for help with GHC.js, as I mentioned earlier, and to my colleague Anders Lowe for playtesting feedback. And thank you to all the people who took part. I mean, it wouldn't be any good without the hundreds of teams and hundreds of people who take part every year. So thank you to all of them. So, okay. Oh, I see. We've got VGA. Ah, okay. Maybe in the meantime, I will take questions. Put your hand up so I can see it, or just shout out. Here we are. Question.
So just wondering, what were the most obscure languages used?
Most obscure. So I'm afraid I don't actually know. I was away on holiday when the rest of the team were doing the judging. So, so I've not looked at that very carefully. We will publish the full list of results, which includes the self-reported language choice. There were quite a few custom languages, actually. I mean, some were custom made for the contest, right? Because people had to compile from some high-level language down to GXC or GCC. But there were one or two other languages which people have been hacking on in their spare time, which they decided to use. Okay, I will hand over to that.
I can use this mic, right?
Yes, that mic works.
Great. So I understand we don't have a lot of time, so I'll try to be really brief. But I actually have a lot to tell about all the sufferings that I inflicted upon myself. So, yeah, I think that pretty much every team followed the same general plan, with a few exceptions. It was obvious that this was not practical to code the artificial intelligence directly in the assembly language, so everyone needed some sort of high-level language. And this is a general plan, this is my version of it, so I took a few decisions here. Of course, after the lightning round ended, we also had to augment our plans a little bit. And yeah, I have to say a lot of these decisions are quite myopic and caused me a lot of pain later. Okay, so apparently I'm one of the least fanatics, so this is how I perceive the form factor of different parts of this task, and allocated my time accordingly. So you can see that I spent most of the time actually coding the AI for the Lambda man. Ironically, this is how I think it actually played out. I didn't see the tournament results, but I think the Ghost performance was very important, judging by various homebrewed contests on Reddit that participants were running among themselves. Anyway, so a few details about my solution. The high-level language is Lisp-like. It looks like this, so nothing special really. But it's almost purely functional. Really, the only effectful thing there is do debug, obviously used for debugging. And it has quite a lot of quirks. For example, for no good reason really, I didn't have general tail call elimination. And this also really screwed up my call convention, despite the fact that there was good call convention in this path. I used something completely different. Yeah. All my ifs must be in tail positions. There's no support for the cell instruction, so yeah, this is another design decision. And yeah, buildings, well, all primitives are not really first-class entities, so they can be used with higher order functions. And no macros. Please don't tell anyone I don't actually like macros. I think people should be just using, lazy evaluation and high-order programming. But for those of you who do like macros, don't worry. This actually came back to haunt me later, so and well, it was quite a pain to debug, for a quick job of compiling that. Now, additionally, I should mention that I think I really should have implemented this as an embedded DSL. This could have given me some type safety almost for free and solved a lot of problems, so this is another mistake on my part. I had a couple of really nasty compiler bugs that I discovered only really late into the contest, so some tips for your enjoyment, you can see what's going on here. Okay, and just a few words about the AI. So retained a very early version of my AI as a fallback, since the main AI may not return a move in some situations. And the main AI uses breast for search, nothing fancy really. It's just looking for something edible and trying to move there. So these are some details we'll skip for now. And data structures, nothing fancy here either. I'm just using some binary search trees and a simple queue from purely functional data structures, the simplest one possible really. The AI also propagates ghosts to kind of predict the future, because it's not really practical to emulate the ghost AIs given the sources. But this is what I'm doing. So knowing the initial state, I'm trying to move the ghost until he reaches an intersection where a decision must be made, since while moving in the tunnels, ghosts can't really, make any choices. They're forced to move in the same direction they started. Yeah, and there's some discounting to basically prevent my lambda man chase something that he really shouldn't be chasing. There are quite a lot of quirks. So, for example, the lambda man never chases ghosts that are running over pills for some reason. Well, for simple reasons that it terminates on finding anything edible. And the lambda man is also something of a scarcity cat, since it uses quite pessimistic estimates of ghost behavior. There's very little global preprocessing. This is also something that I regretted. Unfortunately, I never really had the time to do anything about this. And I also realized after the contest that I have a lot of unnecessary preprocessing on each step. Once again, this is something I only realized much later. AI state is also quite fragile. So, for example, if AI times out, it may screw up its future behavior. Well, as I said, it's not really practical to emulate the ghost AIs, mostly because on really large map with a lot of ghosts running around, it's easy to estimate that there simply aren't enough cycles for the lambda man to run off the AIs and get a good prediction of their behavior. Ironically, once again, I run into cycle limit anyway, so this is a dreaded cycle limit, and despite the fact that I was using rather simple algorithm, I still encountered this problem, and I was really distressed by this, because I didn't really know what to do. It's hard to estimate the cycle spans annually from inside the simulation, and the profiling was basically impossible. I used the stock implementation, and it's not read-only, it's really execute-only. As Duncan said, it's Haskell translated into JavaScript, so yeah, good luck. And yeah, I really regretted not having macros, because I had no inlining, only by hand, and this was quite painful. So the one thing I did, I implemented some pretty random cutoffs based on the map size, and it seems to have worked, and optimized quite a lot of stuff by hand. So I rewrote my standard list library. I've used some maps and filters in a few places, eliminated some unneeded intermediate variables, since those were using up instructions too. And well, in the end, it seems to have worked. That's the only thing I can say at this point. Ghost AIs, well, they have very limited resources, and as I said, I turned out to be quite a list fanatic, so I didn't really want to spend a lot of time on this part of the task. I wanted something really simple and reasonably robust, so my ghost is very simple. It tries to minimize the Manhattan distance to the lambda man, and there are a couple of problems with that approach. So my solutions were as follows. The ghost index, it affects the tie breaks in some cases, so different ghosts tend to go in different directions on the intersections. And there's also simple algorithms that help the ghost to get out of dead ends and places like the central enclosure on the central map. It's also quite a problem for the generic algorithm. Once again, the end result seems to be quite efficient on many maps, and the ghosts tend to surround the lambda man, leaving him no chance in killing it. So I'm not really sure how this matches against other contestants, apparently fairly well. So my submission sources are available on GitHub, and I'm going to put this in there as well. The link can be found on ICFP subreddit, along with many interesting submissions and reports from other teams. I want to say that this was a really awesome contest, and they always are, but this was even better than usual, and I want to express my heartfelt gratitude for this to the organizers. Duncan, thank you, and thanks for listening to me.
While we're switching over, maybe I can show you running in the background the Hubel's AI. I don't know. Maybe I'll do it later. Yeah? All right.
Can I ask a question? Is there time for a question?
Go ahead.
So I wonder about this feature that the lambda man could look at the code of the ghost.
Yeah,
so you said nobody used it, and what was your intention with this feature, and did your own lambda man use it?
So this was really, we didn't do quite enough play testing there. We got that there.